Hello, science family. Today we want to tackle the idea of the beneficial uses of radioisotopes. Remember, a radioisotope is something that naturally breaks down or decays and gives off energy. We call that energy radiation. But how can we use this to benefit the world around us? Well, there's quite a few. One important thing is called a radio tracer. A radio tracer is really just allowing a radioisotope, remember, that gives off energy, gives off radiation. We can use that to follow a pathway. So somehow we can use this energy kicking off object to see exactly where it's going. So for example, like with iodine-131, we call it a radioactive label because it naturally gives off radiation. If you drink a certain solution or this dye is injected into you, a machine can actually watch your thyroid function, meaning it can follow where the iodine settles and how your thyroid's working. So through a machine, we can pick up that energy, that radiation, in order to detect like where something's moving. Another example would be like barium-140. Barium-140 is a radioisotope. It gives off energy. What you could do is you can have an instrument pick up the movement of barium-140 because it gives off radiation and radioactivity. And you can see like how the silt at the bottom of rivers is moving, so you can figure out like what's going on with erosion of this river and that. So if any of you ever done anything like drank a certain drink before, like an MRI, that's the idea of a radio tracer. We're picking up the energy from that radioactive material with an instrument in order to see somewhere where you wouldn't be able to normally see well, like, inside the body and that. So radio tracers can be very beneficial, especially for humans in medicine, because we don't need to cut you open to see certain things. That's a good thing. Another important thing, of course, is cancer treatment. First of all, what cancer is, right? It's that abnormal cell growth that eventually turns into something like a tumor. All right. So if you look like at an x-ray and there's an abnormal growth like in the lungs, unfortunately, that's a tumor. We would call that lung cancer. So how can radioisotopes help us fight cancer? Well, we can fight it by using the radiation or the energy in order to destroy those cancerous cells. All right. A popular one is cobalt-60. Cobalt-60 actually gives off gamma rays. You guys know that gamma rays is very, very high energy. And if it's directed on those cancerous cells, it can kill them. The byproduct or the side effect, though, as you know, is some cancer treatments with radioisotopes also kill any fast-growing cells, not just cancerous cells. So that's why things like your hair and your stomach lining to become nauseous, those things can actually be reduced because the radioisotope radiation actually harms the good cells as well. So that's why it's really hard on the body, some types of chemotherapy with radiation treatment, because even though they're trying to own in and know exactly where to treat that cancer, it can still affect good cells as well. Something that surprises a lot of people is that radioisotopes and the radiation can be used for food preservation. Well, what does that mean? Think about strawberries. Strawberries have little tiny microorganisms or bacteria growing on it that are going to speed up the process of those strawberries rotting, right? They're going to ripen and then eventually rot. So what if we could blast those strawberries before we ship them out to stores with high level of radiation, like cobalt-60, the same radioisotope that could be used to help treat some types of cancer? Well, would that freak you out? Well, it shouldn't. The radiation would be blasted and kill off all that bacteria. So what that would do is that would prolong the shelf life of things like strawberries, because we would start over the process of bacteria growing on them. So we call that basically cold pasteurization, because you're not heating it up to kill it off the germs. You're doing it in the cold temperature, like a regular room temperature. But cobalt-60 can be used to do that. If you look at the bottom here, there's a lot of other things that can use this idea of cold pasteurization to blast the food with radiation. Now, a lot of people think, well, wait, is my food radioactive now? No, absolutely not. Remember, the gamma radiation is going to go right through this and keep moving. And from there, though, that bacteria, it will screw up the DNA of that bacteria, and that bacteria will die. So Pretty cool idea that we can extend the shelf life of fruits so that we don't waste as much food. We know that world hunger is an issue. The more we can preserve food in a safe way, the better. This is kind of how that idea of blasting like the strawberries works with cold pasteurization. But basically, it's through a conveyor belt. We're going to bring the materials through. They get hit with the gamma rays from the cobalt-60, and then eventually we ship them onto trucks and ship them off to wherever they need to go. So radioisotopes can be very beneficial. A lot of people get nervous about radiation, and it's okay to be concerned about that and aware of it, but there's also some benefits from it. Also, don't forget about when we talk about radioisotopes, it's good to mention again nuclear power. Even though there is, of course, the side effects of the waste, what do we do with it in that? The idea that there's carbon-free emissions is something that is very tempting to look more into because we're not burning fossil fuels, which can, of course, harm our climate change issues by putting more carbon dioxide into the air. So in the end, there are a lot of good sides. And if you haven't noticed by now, radiation is a double-edged sword. It can harm us and it can help us. But hopefully this just enlightened you a little bit so you got to see some different sides of radioisotopes and their uses. Take care, science fan.